This is Mr. Collier, and today we're doing the scalar product, sometimes called the dot product because of the symbol we use. A scalar is a more apt term, and it comes from cosine rule, basically. We just use cosine rule in a vectors context. So the coordinates of A are a1, b1, a1, a2, and coordinates of B are b1, b2. We're going to develop the scalar product in a second from cosine rule. So look at this angle and we want to use cosine rule. Then we have this side squared, so AB so it's a vector, so the distance or the magnitude of the vector is magnitude squared. So it's just cosine rule, right? We're going to have magnitude of A squared plus magnitude of b squared minus 2 magnitude of A magnitude of B cosine, let's call it theta there, theta, okay? So this is AB. Remember, to get the vector AB, you do head minus tail, you do B minus A. So this works out to be, by Pythagorean theorem, we do head minus tail, so that we're going to have b2 minus b2 is the y value, and this is a2 minus a2 squared plus b1 minus a1 squared, and that's the magnitude of A. Alright, so that's just root a1 squared plus a2 squared. Should have little arrows everywhere. No, those aren't arrows, those aren't vectors, those are just coordinates, right? Yeah, squared. And this one here, the magnitude of b squared is very similarly b1 squared plus b2 squared, and all squared, and then minus 2 root a1 squared plus a2 squared root b1 squared plus b2 squared cosine theta. Okay, and we'll simplify over here. Okay, we get square root squared. I forgot the square right here. So the square root is canceled effectively, and we've got just b2 squared minus 2a2b2 plus a2 squared, and over here we're going to get a b1 squared, and we're going to get a minus 2a1b1 plus a1 squared. And on the right hand side of the equation, this cancels and we get a1 squared plus a2 squared plus b1 squared plus b2 squared. And over here, actually over here I don't need to simplify that because actually I want that. So let me just back up and keep it like that. Magnitude of A, magnitude of B, cosine theta. So let's just keep that the same. Okay, and over here we have b1 squared on the left and b1 squared on the right, and the same thing with the b2s and the a2s and the a1s. They all cancel, and you got negative 2. Let me just rewrite that slightly. a1 b1 minus 2a2 b2 equals negative 2a magnitude of A magnitude of B cosine theta. And divide by negative 2 and you get a1 b1 plus a2 b2 equals magnitude of A magnitude of B cosine theta. So what this equation is very useful. It just tells us if we do a1 b1 plus a2 b2, we can figure out the angle between two vectors. So the dot product is very useful for finding the angle between two vectors, or if we know the angle, we can figure out other properties, okay? So it's so special that we call this the scalar product. That's the name of it, okay? So the scalar product is like for a two-dimensional vector a1, b1 plus a2, b2, okay? And like it says, called dot product, so we indicate this product like this, a dot b. So whenever you see a dot b, you do this because it's related to the angle between the two vectors. Let's take a look at the IB formula booklet. It's in the formula booklet. Here's the scalar product right there with a little dot. And this is 3D, so you have an extra term there. But that is the scalar product. And this is the formula we just derived, so you can figure out the angle. And this is the same formula rearranged for cosine. But the numerator, they've actually written out the dot product, as you can see. Instead of v dot w, they've put the whole thing in there, right? So this is the dot product, and it's totally related to the angle between two vectors, so it's very useful. Okay, so we can find the angle between two vectors here. We can use this, right? Cosine theta equals a dot b over magnitude of a, magnitude of b. And that's it. You just got to figure it out. So the dot product is by definition, a1, b1. So that means do 1 times 2 plus 3 times negative 1. And that is negative 1. Okay, that's your numerator here. Your denominator, you can figure them out pretty easily. Right, that's root 10. And then this one is root 2 squared plus 1 squared. Okay, so that's negative 1 over, that's root 10, root 5 is root 50. So cosine theta equals that, and then we can just put that into your calculator and find the angle between it, right? Okay, we often use degrees for vectors, but it could be radians, doesn't matter. Just waiting for my calculator to open, it's taken a while. Okay, so I got a radian mode. I'm just going to change it to degree mode, and I'm going to do our cosine negative 1 divided by root 50. Oops, I did 0.550. Okay, 98.1. So theta is 98.1. So if I draw the A and the B, and the vectors matter, they're going to be slightly more than a 90-degree angle, right? Okay, this is A, B, and then you get 98.1. Okay, now if you did negative A dot B, then actually you would get this angle. Okay, you get a totally different angle, but that's something for another day. Find the angle of the triangle. So this is the same thing, but you can draw the triangle A, B, C. Find this angle. If you want to find this angle, then we need to get these vectors, and the arrows matter, and that'll give us this angle. Okay, so you need to do AB dot AC. Okay, not BA. It's got to be this direction, or actually you could do BA and CA. You'll still get the same angle because it'll be like this angle right there. Okay, so you do that and this method, and you can get the angle between the vertices of a triangle. I'll just leave it as that for now. This is a very important feature. Notice in the formula, this equals cosine theta, right? And what happens when theta is 90 degrees? Cosine 90 is 0. So the whole right-hand side cancels when you have a 90-degree angle, right? So that means if you've got A dot B equals 0, then you've got perpendicular vectors, because the cosine cancels out here. So it's a very important feature. If you, like here, you want to find K, and we know it's perpendicular, then we just have 2 negative 1 dot K, 4 equals 0, and then solve for K, 2K minus 4 equals 0, 2k equals 4, k equals 2. You do the same thing in 3D. Let's check the angle between these two guys. Just do the dot product first, and you don't have to worry about the entire formula, because if the dot product is 0, we know what the angle is. It's a 90-degree angle. So you get 2 minus 2, plus 4, so that's not a 90-degree angle, then that's 4, so it's not a 90-degree angle. I guess you'd have to use the formula to find the angle, but I'm going to leave that as an exercise for you. This is an interesting problem. What is the angle between two diagonals of a cube? This is really not easy to do without vectors. It is much, much easier with vectors. You can think of this as, for example, maybe you can put the origin here, or anywhere you want really. And then to make it simple, we can call this like, let's call that 1 in the x direction. And this point, we'll say this is x, y, z. I think this way people normally do it. Z going up and down. So this is the y direction, so that's 0, 1, 0. And this one has gone 1 in the x and the y. I'm just choosing 1 arbitrarily because this cube is bigger. It doesn't matter. You get the same answer. These points up here, we've gone up 1 in the y direction and 1 in the x direction. Sorry, the z direction. Okay, and this point here, we need that point right there. It's just up 1 on the z. And we've got all the endpoints of these red lines here. So we can actually figure out the angle now by doing this formula. Cosine theta equals, so actually let's make a vector here. Let's call that A and B, and this one B. Okay. So A, to get that vector, we're doing head minus tail. 1, 0, 1 minus 0, 1, 0. And that is 1, negative 1, 1. And B is head minus tail. We've got 0, 0, 1 minus 1, 1, 0. That is negative 1, negative 1, 1. So I'm using this formula. The dot product's in the numerator. So we're going to do 1, negative 1, 1. Dot negative 1, negative 1, 1. Divided by the magnitude of, now the negatives don't matter when we're doing Pythagorean theorem here. So you get the same thing. So cosine theta equals, this is negative 1. Then multiply these guys plus 1, and then another 1, so that's 1. Denominator is root 3 times root 3, so it's 3. So theta equals arc cosine 1/3. Let's check it out. Arc cosine 1/3 is 70.5. So a bit surprising. If you ask somebody, just by looking at the picture, people might think it's 90 degrees or something like that, but it's actually not. If you actually were to look at some cube in 3D and check it out, that angle between the diagonals is actually 70.5 degrees.